Okay, today we're going to start lesson 8-3, which is transformations of quadratic functions. We've already done transformations before with linear functions, where we shifted lines left, right, up, down, and reflected across the X or Y axis. So we've done that part. Now we're going to do this with parabolas. And actually, when you transform quadratics, it's simpler to me than the linear functions. So hopefully this will be simple for you as well. Okay, so a couple of vocabulary words, which will be on a quiz, probably your test 2. So when you shift a parent function up, down, left, or right, that is called a translation. Okay. If you reflect a parent quadratic function over the X or Y axis, reflection. That's obvious. Okay. On your quiz or test, it may say it crosses the X or Y axis so that I don't give it away in the definition. It draws a parent quadratic function closer to the Y axis. This is called a stretch. So the way that I can explain this is when we ordered our equations from narrowest to widest, we found that the narrowest parabola had a larger a value, right? And so if your a value goes from a smaller to a bigger value, then your graph is becoming narrower or it is stretching. Okay. Am I saying something wrong? I've got some like eyebrows that go like that. Yeah.
When I think of stretch, I think of big.
No, that's wide. That would actually, that's getting wider, which will eventually get flat. And so the next one, when it draws the parent quadratic function closer to the X axis, it's a compression.
That's the opposite.
Okay. When you compress something, you are flattening it, right?
Yes.
Think of your parabola. The wider it is, it's drawing closer to the X axis, the flatter it's becoming. That's why it's a compression. But if you're drawing it closer to the Y axis, it's stretching. I know.
It would like stretch like. It's weird.
Okay, it is weird. It is a little bit weird.
Like
Okay, so in looking at some of these instructions, a vertical translation shifts a parabola up or down on a coordinate grid. It also can shift left and right, but we're going to do that in just a minute. So vertical, if I'm going vertical, am I going up, down, left, or right? Is this horizontal or this horizontal? Is this vertical? Which one's vertical? This or this?
The second one.
Okay, this one, right? So you're going to be a vertical translation will shift up or down. Okay. And then on the back page, a horizontal translation will shift it left or right. So we're going to look at what these two mean. So you take the parent function. Remember, we talked about in our last lesson that the parent function has a table that looks like this, where you have 0, 0, and then 1 squared, and the equation looks like this. And so 1 squared would be 1, 2 squared would be 4, 3 squared would be 9. So this, when it talks about the original parent function, this is the parabola it's talking about. You could have a parabola that serves as the parent function at some other place on the graph, and they're asking you to translate or transform that function to a different function. That original function can always be the parent function too. So when you're transforming a parabola, the parent function is the original function or the original parabola on the graph that you're transforming. Does that make sense? A little of you. Okay. So for example,
Just show us.
Show us the
I learned by you showing us.
okay,
That's
I will show you. Let me get some.
I'm trying to explain. It's just harder.
Okay, so if I have a parabola graph like this. Okay. And this represents y equals x squared. This is my parent function, okay? And then if I asked you to transform this and it ended up here, meaning that I shifted it down and then I shifted it to the right, this would be the transformed or translated function. So this was my original function, which we call the parent function. This is my transformed or translated function. Now, okay. Then if I had a graph and I had a function like this, well, this is y equals something. I don't know what it is, but I asked you to translate or transform this one and it ended up coming over here like this.
Yeah.
Okay. This is my parent function. This is my transform function. So my original or parent function here. So typically when we say parent function, the parent function is always y equals x squared, typically. But if it's asking you to transform something that looks like this, then this would be your parent function. Okay. But if I ever said graph a parent function, I'm asking you to graph this. All right, let's go on. Okay. So in a vertical translation, you take the parent function y equals x squared and you add or subtract a value to or from the x squared. And this is represented by the letter K. So look at this right here. We're taking the parent function x squared and we're going to add something to it, or we're going to subtract something from it. When you see that happening, that means that you're raising the parabola up or down. Okay. So let's look at example 1. F of x is replaced by f of x plus k, where k equals -3. All that means is that you're taking a function, f of x equals x squared, and you are subtracting 3. What is happening to the parent function when you subtract 3?
Vertex
Yes.
will go down.
Yes, so the parent function is shifted down 3 units.
Is this just describing the graph?
Mhm. You're describing the graph based on an equation and not by actually graphing it.
So this only works on the ones that are just x squared.
Yeah.
Okay. Example 2. You now have the parent function f equals x squared translated to f of x equals x squared plus 5. What are we doing?
We are translating it up. Or 5.
Yeah, we're translating it up 5 units. What this means, and you can write that down, the parent function is shifted up 3 units. What you're actually doing is you're taking every plotted point in your parabola and you're just moving it up 5 points. Okay, so. Okay, so now we're going to look at this graph. The blue line represents the parent function. So next to this blue line right here, you're going to put parent function. Oh, sorry. Yep. Okay. Now, for each line, you're going to tell what is happening to the parabola. Okay, this should be pretty easy. So the red line is shifted up 1 unit. The green line shifted down 1 unit. The purple line shifted up 2 units. And the yellow line is shifted down 2 units.
They don't like stretch or anything, 'cause it looks kind of.
No, these, yeah, this, it isn't being stretched. Okay, so this one was pretty easy. And what's gonna happen is this equation right here, y equals x squared plus k, we're gonna keep adding to that equation until we get a larger equation that represents all the different possible transformations you can make with the graph. Okay, so let's go. Okay, I know. All right, so we're moving from vertical translations to horizontal translations. So this will shift the parabola either right or left. So the final equation looks like this. Oh, sorry. Y equals a times x minus h squared plus k. Okay, the vertical, I mean, the, oh, I'll change that when we get to it. Yeah. So what we did was the K just a minute ago. The K represents, and I should have had this on here, a vertical translation, okay? All right, the H represents a horizontal translation. Okay, and then when we get to the A, I'll explain that. So K is the vertical, H is the horizontal. So let's look at this one right here. This one is actually opposite of what you think it's going to be. You're going to take the parent function and you're going to add or subtract a term represented by the letter H to the X and then square it. So that's a little bit different. Now, when you add, when your H is positive, you are actually shifting your parabola to the left in the negative direction. Okay, because let me show you. All right. If I had, say that I wanted to shift it 3 units to the left, okay, that's a negative number. We're going in the negative direction, right? But when you subtract a negative, it becomes a positive. Does that make sense?
No.
Well, yeah, it makes sense in that sense,
Okay.
but then it really a
Can you just
positive
show
and a
us a
positive
visual?
makes a positive.
Just give an example.
Okay, let's do this right here. Maybe this will help.
Weird.
Okay. If we're replacing the H, which is a horizontal translation, with a 7 here. All right. This 7 is actually negative. Okay. So watch. Let me just show you. F of x equals x minus h squared, right?
What?
This is the formula
For right.
for left or right.
That's just
Oh,
for
I
right,
see
it
what
says
you
no.
mean.
Wait,
Okay.
I thought I was just for right.
Oh, here, wait a minute. Let me pause this really quick, just to make sure. Okay, so we have to change 2 things on our notes. This H should be a -7, and this 2 should be a positive. Okay. So what we're wanting to do is we are wanting to translate our parent function -7 units. So what that means is that we want to translate it to the left because that's the negative direction. So when we plug it into our formula though, it becomes a +7 like this. And I'm going to show you how that is done. So our parent function is f of x equals x plus, x minus h squared. Okay. Okay. But again, we want to translate it 7 units to the left, which is a -7, because to the left is negative. So I'm going to plug -7 into my equation. Okay. Now we know that subtracting a negative becomes a positive. So what it's actually going to look like in the equation is x plus 7 squared. Okay, so if you're translating or if you're describing a translation based solely on the equation and you see a positive number as h, it's going in the opposite direction of what you think it would because it went in as a negative. So it's going to go to the left. All right. So in describing this, you would describe it as the parabola is being shifted 7 units to the left. So I want you guys to write that down right here. Yes.
So with your final answer, it being +7, wouldn't that technically mean moving it 7 places to the right then? Technically?
No.
Okay, I just explained all of that. So can somebody else in your own words explain it? Go ahead, Alex.
So basically, for this entire thing, you're gonna start out with f of x equals x minus h squared.
Yes.
And so, but when you start, you're plugging in a -7.
Interesting.
Okay,
So-
wait, -7. What direction is a -7? Left. So that's how many units you're gonna move it to the left. But
When you put it in a negative, x minus a negative,
It becomes
it
positive.
becomes positive.
so it looks like positive,
It
but
looks
you
like a
plug in-
positive, but
Mhm.
put it to the left.
Wow.
because you plugged it in as a
Or
negative.
so get it.
Oh, that's nice.
That's it.
Oh.
Okay.
I thought there was something I missed.
I'm going with, I'm putting
I
it
thought it was
hard.
just-
Okay. Here we go. F of x, the parent function is replaced, the h is replaced with a +2. So we're going to take the parent function. We're going to plug the +2 into the equation. Remember, positive goes to the right, but once we plug it into the equation, it's going to be a negative. It looks like it's going to go to the left, but it isn't. So x minus 2 squared. And you just can describe it as shifted 2 units right. Okay, questions? Ben?
If we just memorize this, do we actually have to plug in the
No.
numbers?
No, I only plugged it in to show you. All you need to do is be able to analyze the equation and describe what is happening to the parabola. All right, in these graphs here, which one is the parent function? The middle, so the black.
So is it always going to the x or?
Mhm.
Okay, so. I don't know, but technically speaking, this is on our homework, how are we actually supposed to?
The parent,
X squared in that equation.
Because it's at the
Oh,
origin.
parent function
Yeah,
always
it's at
goes
the
to
origin.
zero.
and it was the table where you have x is 1, y is 1 squared, x is 2, y
I
is.
know that, I'm just saying, what if the actual parent function was the red line? And it just got shifted.
Oh, Then that would be the only graph there. And it would tell you, take the graphed parent function and reflect it over the x-axis or translate it 2 units to the right.
So if it was like that, wouldn't it not be a parent function though? Because I thought you said it's only if it's y plus x squared.
Right.
Which would always be. a parent function.
The overall parent function would, it means that it would go through the origin. So that's what we call the parent function. However, sometimes you'll get problems where they say the parent function is some kind of parabola that's graphed and you need to translate it. It's probably misused though.
Yeah.
All right.
We'll show you this one.
So look at the red line. We already know that that is a horizontal translation 2 units to the left. I want you, it's okay. I want you to, guys, focus over here. I want you to write the function here. All right. So f of x equals x plus or minus 2?
It's gonna be +2.
Plus
It's a
2.
negative.
Yeah,
I figured it out.
Wow.
okay, and then this one will be f of x equals x minus 2 squared. All right, I want you to do examples 7 and 8. Oh my goodness.
Everything's fine.
Okay.
I'm perfectly safe.
Okay, so here's example 7 and 8.
I'm 6 and 2.
Okay, move over.
Yeah.
Okay, we're now doing reflections.
Sorry, my mind's scrambled.
Okay, so if you are reflecting a parabola, then your x squared will have a negative in front of it. Okay, that is basically all that it is. Okay, and what it means is that your parabola will shift from opening up to then opening down. And the points are equidistant from the x-axis or your center. In our case, for Algebra 1, they'll be graphed on the x-axis. So then each of your points are equidistant from the x-axis. Okay. So in this case, determine the effects of the parent function f of x equals x squared when f of x equals negative x squared. So what is happening? It's shifting over. What? What did I just say? In that reflection, it's shifting over which axis?
The x-axis.
The x-axis. Okay.
That's amazing.
I zoned out.
Oh, sorry.
How did it shift? I thought it reflected over.
I mean.
Sorry to whoever's watching this recording.
There's only one.
It's only Madison.
It's gonna be Madison.
Oh,
She'll roll her eyes at me. I know it. Okay.
Well,
She'll be like-
she
she'll
should
come
get
back.
used to it. This happens all the time.
I know.
See, I would.
Thank
too,
you
but I don't-
for your support. Okay, look at the horizontal, not the horizontal, the reflection over the y-axis. The difference between the vertical, I mean, the reflection over the x and the reflection over the y is that over the x, you're actually multiplying the entire function by a negative. So let me give you an example. If you had f of x equals x minus h squared plus k, okay, that's what we've seen so far. If it is shifted over the x-axis, that means your negative is going to be in front of the entire function, and that whole thing has to be multiplied by negative. If it's shifted over the y-axis, it's going to be just multiplying the x by a negative. Okay? Yes.
On the parent function, though, isn't that the same thing, like the example? Negative x squared is x squared.
This one right here? Yes. If your parent function is the typical parent function and you flip it over the y, it's the exact same thing. Yeah. It is the
So
same
there's
thing.
no.
Okay. So in this case, down here, example 10, when f of x equals, in parentheses, you're just multiplying the x by a negative, it's going to reflect over the y-axis.
So it's, yeah, on our homework, if it tells us to do it,
They're
we're
exactly.
just not doing it.
So I'm going to tell you for all of your homework and what we're doing, we're just doing the reflections over the x-axis.
Oh, we are.
We
There's
are?
no hard horizontal.
No horizontal.
Yeah. So there's.
Okay.
Why did teaching us that?
Because, all right, so yes,
Nine and 10 are exactly the same, so why the answer?
Because
No, one
No,
has
no, no.
parentheses over it, and one has.
right here, you're multiplying the entire function by a negative. Over here, you're just multiplying the x by a negative. So look at what I did over here.
Isn't the X being on number 9 too, because this negative is gonna be at.
Okay, look at what I wrote up here. And maybe this will make more sense. See how the negative's on the outside of the parentheses?
Yeah.
That means I'm gonna multiply this whole thing, whatever the numbers are in here, by negative. Notice how the negative is in parentheses right in front of the X. I'm only multiplying X by negative, not the H also. Okay, so if you look at example 11, this first set of graphs, Andrew, what were you gonna say about it?
I know the answers tonight.
Okay, what is it?
Okay, so for the first one, it's reflected over the y-axis, and the second one is reflected over the x-axis.
Yes,
Wow.
But you have to move it down a little bit.
well, thank you. All right, so we've done translations, horizontal, vertical, we've done reflections over the X and Y axis. Now what do we have? I know, we're not gonna finish this.
Oh, darn. Oh, darn, guess we don't have any
No.
more words to train.
That's just.
It's just too complicated with so many words and ways.
Guess we don't have any more.
Hey, oh, wait a minute,
Oh.
how many pages does your notes have?
Six.
They have 6, lots of pages.
Okay,
Miss Weatherby, we have like 6 pages and we're only on the 3rd. We're only
Okay.
halfway home.
we're gonna get there. Okay, here we go.
I don't think we're gonna get less than 10 minutes.
Thank you, Jen. Okay, vertical stretch. Vertical stretch. We've already gone over this when we ordered our functions from narrowest to widest. So if you look at this one, if you go from 1 to 2, you know that you are making a narrower graph, so it is stretching towards the y-axis. That's why this is called a vertical stretch. If you look at the second one, it is less than 1 or less than 1, it's smaller than the parent function, so it is compressing further from the y-axis but closer to the x, so it is flattening out. That's what we call it, a compression. So look at examples 12 and 13. I want you to determine if it is a vertical stretch or a vertical compression. Okay, somebody tell me what number 12 is.
Stretch.
Stretch. That means this one is a vertical compression. Okay, look at your graphs. So on this graph, we're looking at the parent function compared to the red parabola, 1/4 x squared. What is that one?
So the parent function is blue.
Yep, the parent function is blue.
What is the point of this?
So from red to blue. would be
Just
vertical
ignore that one.
From the red to the blue would be vertical compression.
Yes. Because we're compressing the line down.
So the red is the parent function?
No, the blue is the parent function on both of them. The red is the transformed one.
So basically, this entire.
And we
lesson
ignore
is
the
just
green
about
one?
Yes.
figuring out basically all
Okay, so that one was pretty easy because we've kind of already done it. So let's go to page 5.
Oh, no, let's not go so fast.
Okay. So what was that, Christian? What was that?
You didn't have to cut me off. Oh, no, it's like that.
All right, so now we're going to describe and graph multiple transformations. So we've just looked at single transformations, but now we're going to combine a couple. Yes.
Can you say this formula is messed up?
Yeah, 'cause
Yeah.
it's-
So basically just get rid of the C.
Yeah.
So why was the she doesn't
What was
even-
the C supposed to be?
It is talking about, yeah, we're not going to do that.
But isn't also the C the third variable in the quadratic equation?
Yes.
So why would they repeat the same thing?
Maybe it has something to do with it.
Maybe.
You don't even know what it
I
means.
don't. That's why we're not doing it.
What?
I thought-
Did you
Just
make
cross that
these
off.
I thought you
answers
were a
up?
math.
No, I
Yeah.
don't think you made.
All right,
Mr.
the parent function, f of x equals x squared.
You don't like this problem.
I am.
You are.
F of x equals x squared
Why did you say I am to that?
has been transformed with this one. Gentlemen, you need to zip it, please. Okay, so I want you to describe the transformation and then I want you to graph it here. So you're gonna graph example 18 here. And then you're gonna graph example 19 here. The first thing I want you to do with your pencil is graph the parent function. And then with one of your colored pencils, I want you to graph the transformed function.
Why did we need 4 colored pencils for 2 colors?
Because we're gonna use the other ones on the next page.